last time I'm going to do this, I want to make sure we are clear on the difference between when I ask for experimental versus theoretical. Right. On this example here, you got a spinner that says green, blue, red, and yellow. All right, green, blue, red, and yellow. You're just going to spin it once. This guy spun it 20 times and recorded his results. So first, let me go to theoretical. Theoretical is what you should get. All right, forget about the results that you got, what you should get. So the first thing here, looking at this spinner, what should be the probability you end up with a red? Just using that spinner alone. I could care less what he got over there. I'm not there yet. Using this spinner alone, what's your chances of getting a red here? 1 out of 4. And also, I'm going to do a lot better job here of my notation. P for probability, and then whatever's inside the parenthesis is what we're looking for. All right, let's keep going here. What's the probability you get a green? Green on this, green. Also 1 out of 4. They're all going to be 1 out of 4. Everyone see that is theoretical, what you should be getting. So green, yellow is a quarter, and so is blue. All right, now you do an experiment, a trial, a simulation. Now you tell me the experimental probability based on what you did here. So how many reds came up? 5 out of, how many spins did it say? 20. So that reduces down to 1/4. All right, what's the probability, experimental probability of a green? 9 greens out of 20. Everyone see why it's different than the 1/4 we got? This is experimental. Probability of a blue. 3 blues out of 20. And then the probability of a yellow, 3 out of 20 as well. Let's guess which one does the experimental and the theoretical match each other for what color? For the red. For the red. So we all good on when we ask for experimental. You're looking for some, what did I do? Did I spin? Did I flip? Did I roll? Yeah, they should. I'm going on to a different today. Okay, let's go. Make sure you have your calculator with you. All right, first we're going to do 2 events at once. Events at once. So roll the die, maybe find a probability, certain probability. Here's what I need off to the side. And I know you have it down here, but it's very hard to read. Probability of A and B. Okay, probability of A and B. That's going to be equal to the 2 probabilities separate multiplying. And I see the word and in between 2 things. I am thinking multiplication, multiplication, multiplication. All right, so when I see the word and, thinking that I'm going to multiply 2 probabilities together. All right. When we do an and one, when we see an and, it could be what we call dependent or what we call independent. Dependent, independent. Let me go over the first example with you. Then spin a spinner. I want to know, are those 2 independent or dependent events? Here's how you can tell. Ready? You roll your die. Does that rolling the die have any effect on the outcome of the spinner? Does rolling the die have any outcome on what the spinner shows? Absolutely not. So we say they are independent of each other. The first event has no effect over the other. Okay? Independent. Everyone good there? All right? Me rolling a die has no effect on what I get on the spinner. Pick 2 flashcards from a stack of 30. Now, if it does not say, we assume we do not replace. Assume without replacement if it does not say in the problem. Okay, assume no replacement. So you pick a flashcard, put it off to the side. Does that have an effect on your chances of the second flashcard? So you pick a card out, put it off to the side, pick another card out. Is that going to affect what you get there? Yeah, why? There's one less in the deck now. All right, so these are dependent. One affects the other. Okay, one affects the other. And then you guys read through number 3. Take a coin out of your pocket, put it back in, take another coin. What do we think there? Does that first pick have any effect on the second one? You put it back in your pocket, does your chances change? These are independent of each other. So if you replace it, look, if you replace it, it's independent. If you don't replace it, it's dependent. Okay? Questions there before we go into some probability questions? Okay, here we go. You can read through the bag I have. Okay, so probability of selecting a black, then a yellow. So this tells me right here, multiply, multiply, multiply. You're going a black and a yellow in that order. All right. P for probability. I want you guys to start to using some of the symbols too. Probability, I pick a black, and you guys can abbreviate however you want. Black, then yellow. Okay, black marble first. Black marble first from all these. What's the probability you pick a black marble first? You guys remember your numbers or no? We got to do this again. Remember our numbers? Here we go, 5. Probability you pick a black here first. How many black marbles are there? 6 out of, add those bad boys up real quick. 6 out of 21. Times, because I know it's an and problem. What do I do with that marble after I pick it? According to the problem, what do I do with the marble? Replace, replace, replace it. Now you need a yellow. So I put that one back in. Now I need a yellow. 7. How many yellows are in the bag? 4. And still, how many total marbles? 21. If I kept it, I change that to a 20. All right, little quick refresh on multiplying fractions. Do it in your calculator if you got a fraction template. If not, numerator times numerator over denominator times denominator. Okay, multiply the numerators, multiply the denominators if you don't have a fraction template on your calculator. And what do we end up getting? I don't know. I haven't the non-reduced. Some of you guys, if you use the fraction template, may have the reduced answer. I'll take either one. 2, what do we end up here with? How's that sound? Because I don't have the reduced answer. I have 24 over 441, which still would be fine. What was it? 8 over what, Nick? 147. Good. Okay. So those are your chances. Pretty slim chance, huh? Questions there? All right. Let's go to Cindy. On the quiz on Thursday, I will write up on the board the makeup of the deck of cards for you. So you don't have to remember. That's one less thing you got to remember. All right, I will remind you guys what the deck of cards is made up with. Find the probability she draws a 2 and a 5 and does not draw a 5. Oh boy, we're in for it. Okay. So 3 things we're going to multiply. We're going to pick a 2 first, a 5, no 5. Yeah. Ready? Okay. First one, pick a 2 out of a deck of cards. Pick a 2. Again, if you don't know the makeup, I'll help you out. 3. Remember how many 2s are in the deck? Who's got 3? Nobody's got. Okay, thank you. 9. Remember how many 2s are in the deck? 4. How many total? 52. So 4 out of 52 chance I pick the 2. Stay with me now. What do I do now after I pick the 2? I don't put it in. Do not put it back in. But now I need a 5. Times, here we go. 8, how many 5s are in the deck? 4. But now how many cards are in the deck? Remember, I only picked 1 though. I'm not picking all 4 2s. I'm only picking a 2. So how many cards are still in the deck? 51. Everyone see that? 51. Because you only can pick a card at a time, remember. Okay, here's where I don't want to lose people. Are we all good so far? Are we all good, guys? Yes, no? Because here's where I may lose some of you. That's where I'm going to go a little slower now. All good. Now you want picking a card that's not a 5. So you have to think to yourself, well, first, how many cards are in the deck now? 50, right? There's 50 cards in the deck. Out of those 50, how many are not 5s? Not 5s. And remember, I've picked a 5 already. Out of those 50, how many are not 5s? How many 5s are, ready? Think about it this way. How many 5s are still left in the deck? 3, right? Because you picked one of them already. So out of the 50, if 3 of them are 5s, how many are not 5? 47. So again, that was a 2. That was picking the 5. And that was picking a non-5. Again, if somebody's got the reduced answer, let me know here. Here's what I'm working with. 752 out of... You guys that are using the fraction templates, let me know what that reduces down to. 13, what's that reduce down to? Yep. It's not giving you a fraction back? It's not? Okay. Okay, then that's fine. Then keep, you guys are using the fraction templates, it's still giving you a decimal? Yeah. Okay, then just multiply numerator times numerator times numerator. If that ever happens, okay? You just multiply your numerator, because we don't want a decimal, so. How are we feeling on the and ones here when I have to multiply? This one was a little tough, especially that last one. Ask it now. Where we get the 47 from, non-5. Good? All right. 2 more, and then I got to go a different type. Tell me if the 2 events are independent or dependent first, then we'll find the probability. So you can read about Jane riding the plane. So the first thing I see, guys, is and. The flight will be on time, and, which tells me multiply. Does either one have an effect on the other? Her being on time, flight on time from Albany to Chicago and raining in Denver, does that have any effect? Okay, no effect on each other. No effect, so independent or dependent, these two then, if they have no effect on each other. 4? Not here?
Independent.
Oh.
No, that's not.
Yep, independent. Yep, independent, no effect on each other. One will not affect the other's probability. All right, so we're going to multiply two probabilities here. Probability that Jane's flight will be on time. What do you got for me there? Actually, 13, flight will be on time. What's that probability? 9 out of 10. I like you put it in a fraction. Beautiful. Or you can do 0.9. All right, if you want to leave it as a decimal. But don't leave 90. All right, don't multiply it by 90 by something. Can't be bigger than 1. So 9 out of 10 times. What about the Denver deal? Rain in Denver. 1, rain in Denver. 1 over 2.5 if you want to put that as well. So both happening, you have a 9 out of 20 chance. Questions there? Going. And then go ahead on the toy bin deal. Does it say what she does after the first stuffed animal's picked? Because it says 2 stuffed animals. Does it say what she's doing with them? I did put that in there? Oh, I did. Oh, look at me this year. I put replacement in that one? Okay, perfect. Without replacement. So if it's without replacing, so I take the first toy or the first stuffed animal, don't replace it, independent or dependent on each other. 1, dependent, because I do not replace the first stuffed animal. Good. So the probability of 2, I'm just going to put stuffed animal. There you go. Okay, probability of the first one's a stuffed animal. Using those numbers, 10, using those numbers, first time, first pick, stuffed animal on the first one. How many are there? 23 total. Yeah. Out of those 23, how many are stuffed animals? 8 times. Here we go. Now remember with what?
I thought it was like.
We good? 23 total. Good on what?
No, I'm good now.
Anybody else? Yep.
It's going to be.
Oh, hold on. Anybody else confused on the 8 out of 23? Okay, don't put the stuffed animal back. Go ahead, Jenna. How many stuffed animals are left now? 7 stuffed animals, but also 22 toys in the bin. I got 56 on top, 506 on the bottom, and then you guys are reducing. What'd you get, 28 out of 253? Yep. There you go. Questions at all? Independent, dependent, multiplying them. Because it is something brand new the second half of this class right now. I see the word and. I'm picking more than one. I'm going to multiply. Questions? Because now I don't want to multiply. There's going to be situations where I'm going to ask you guys to add the probabilities instead. All right, and that is if I see the word now, not and, but or. All right, this or this. So the probability of A or B, and I know these are kind of fuzzy and black and white on your paper, so I want to make sure we're clear on this. It's going to be now not multiplying, but adding the probabilities. And this one's a little tougher because you need to subtract out, after you add them, what they have in common, A and B. And I know I'm throwing a lot at you, but once we do the examples, we'll be fine. We'll be fine. All right, here you go. First one, you're going to roll one die. Probability of a 3 or a 5. What would you guys could probably do that day one of this unit. How many choices do I have? 3 or a 5? 2 out of 6. Where'd that, ready, watch. Where'd that 2 out of 6 come from? What's the probability of rolling a 3? 1 out of 6. Everyone's in agreement? What's the probability you roll a 5? 1 out of 6. And the or in between tells me to do what? Add them. And you also, whoa, you also had subtract out A and B. Okay, you got, all right, ready? On one roll of the die, can you get a 3 and a 5 at the same time? Is that even possible? No. So that's why they have nothing in common. All right, so there's no reason to subtract anything because there's no way I can get a 3 and a 5 on one roll. Yes? All right, so this ends up being, yes, your 2, 6. Less than a 3 or a 6. You guys could probably do that in your head. You don't need it. How many are less than 3 here? Here you go. 6. How many are less than a 3 on a die? What's my chances of getting something less than a 3? 2 out of 6. And then what's my probability I get a 6? All right. Because it's an or, is there a chance I can do both on the same one? Can I get less than a 3 or a 6 on the same roll? Nope. So there's nothing to subtract. What's your probability? 3 out of 6. These events here that we just did are called mutually exclusive. They cannot happen at the same time. They cannot happen at the same time. Mutually exclusive. There's no shot of both happening at the same exact time. Okay? All right, look at 9 now. You're going to pick a card. I'll help you guys out on the cards again. What's the probability you pick a 2 or a diamond? I learned my lesson. I'm not going to draw it. Pick a 2 or a diamond. Watch what happens here now. 6, probability pick a 2. 4 out of 52. The or tells me I'm going to do what to these? Add them, not multiply. Diamond now. Remember, this has nothing to do with or without. It's just one pick of the card. 2 or a diamond. Anybody remember how many diamonds are in the deck? 1, remember how many diamonds? 13 diamonds out of how many cards? 52. Here's where you got to be careful because this did not happen above. Can you get a card that is a 2 and a diamond at the same time? Yeah, you can. It's called the 2 of diamonds, right? And here's what you just did. Ready? I don't do this, but here's the 2 of diamonds. You counted for that one, right? Then you counted it again. So you're counting the same card twice. Can't do that. All right, I can't say there's, I'm just going to count it, and I'm going to count Alex twice and say there's 14 kids instead of 13 in here. Okay? You can't count it twice. So that's why we need to subtract out how many they have in common, which is one card can be the 2 and diamond at the same time. Everyone see what we did, that we can't count it twice. You can go to your fraction template. It's up to you. Denominators are all the same. 14, 4, and 13 is 17 minus 1 is 16. What's that bad boy reduce? What is it? 4 out of 13? There you go. Those are not mutually exclusive because they can happen at the same time. We okay there? Going. You guys have 11, correct? All right. Okay, perfect. We're going to finish right on time. Okay, you got 100 students. 42 are taking French, 26 are taking stats, 8 are taking both. You guys don't have 11 or no? Okay. Did you don't have this. Yeah, I know. I took that out this year. Don't worry. Yeah, I took that out. I know that. I know. I took that out. Okay, a student is picked at random. What's the probability a student is taking French? Or, so that tells me I'm going to add stats. So French or stats. Okay, French first. French, according to those numbers. 4, how many are taking French?
42.
Out of? Okay, so 42 out of 100. The or tells me add stats. 9. 26 out of 100. What do I have to watch out for here? I counted a couple kids twice because there's some that take French and stats. I counted them twice. How many take both? 4. How many take both?
8.
So minus 8 out of 100. These are not mutually exclusive, taking French and stats. Not, because they can happen at the same time. What do we end up for with that one? I have 60 out of 100, 3/5. Okay, I don't know. I'll be honest with you guys. I don't know what's going to happen if you don't practice this. Okay, because I'm not taking a second day to do a group assignment tomorrow or anything else, and this will be on Thursday's quiz. I will answer any questions you guys have at the beginning of class tomorrow, but I can't make you do it. Okay, and it's going to be brutal on Thursday if you don't practice. Cannot make you do it, but I'll answer anything you need tomorrow. Answers are all up on Aspen. Have a good one.